Hi students, this is Razika. Welcome back to the physics classes. From this video onwards, we will start another chapter called Dual Nature of Radiation and Matter. Okay, so in this chapter, initially we will have a brief introduction. Then after that, we will be discussing about electron emission and mainly photoelectric effect. Okay, we'll be studying in this chapter about photoelectric effect. Then few observations, that is about the history, how the photoelectric effect is discovered and what are the theories proposed by Hertz, Halvorsz, Lennartz, etc. Then we will study about the experimental study, detailed study of this photoelectric effect, then Einstein's photoelectric equation and few more things. So for this chapter in dual nature of radiation and matter, you can expect 5 marks questions in the main examination. Now let's understand the phenomena called as electron emission first. Okay, so the liberation of electron from a metal surface is called as electron emission. Okay, suppose idu metal surface anta andre ee metal surface inda electron emission na phenomena na we call as electron emission. Okay, so ee metal alli iro electrons, they cannot just get emitted like that. Okay, one condition ide, yav case alli electrons horgade barutte andre some work has to be done, because ee metal ge ee electrons enagirutte bound agirutte, because the nuclei will be holding these electrons to itself. So these electrons need some energy to get emitted from here. Okay, so ee external energy na we can provide in varieties of ways. Okay, varieties of sources inda ನಾವು energy na provide ಮಾಡಬಹುದು. Either heat you can apply, or light energy you can use, or energy stored in electric or magnetic fields, etc. Many types. Okay, so ee ella energies na ನಾವು metal surface ಗೆ ಕೊಟ್ಟಾಗ what will happen? These electrons will gain energy. Fine. So depending on the sources of external energy, ಇವೆಲ್ಲ ನೀವು external sources of energy, what we have done, electron emission na 3 types alli we have classified. Alright, we have classified electron emission into 3 types based on the sources of energy. First one is thermionic emission. Thermionic emission. Second one is field emission. And the third one is photoelectric emission. Photoelectric emission. We will get to know all these things one by one. And ಇನ್ನೊಂದು ಕೂಡ ನಾವು ಹೇಳ್ಬೋದು, another one is secondary emission. Secondary emission. So based on the type of energy which you supply to this metal surface for the escape of electrons, we have classified the electron emission into 4 categories: thermionic emission, field emission, photoelectric emission and secondary emission. See, in this thermionic emission, name ಕೇಳಿದ್ರನೆ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ. What we have to do, we have to supply heat energy, okay, for the electrons, or for the metal surface can be heated. Okay, so ee metal surface ige heat energy na provide ಮಾಡಿ idrinda electrons liberate ಆದಾಗ ಆ phenomena na we call as thermionic emission, and the electrons emitted in this case are called as thermoelectrons. Fine. These are the thermoelectrons. Next one is field emission. Field emission anta helidre electron emission by using strong electric field at the surface is called as field emission. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಆರ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಗೆಟ್ ಲಿಬರೇಟೆಡ್ and this phenomena is called as field emission. And the third one is photoelectric emission. This is very important in this chapter. The process of emission of electron from a metal surface when light of suitable frequency is incident on the metal surface is called as photoelectric emission. Okay, andre ಲೈಟ್ ಎನರ್ಜಿನ ಈ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿ ಈ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆದ್ರೆ ಆ ಫಿನಾಮಿನಾನ ಆರ್ ಆ ಪ್ರಾಸೆಸ್ನ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಆಸ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಮಿಷನ್. ಅಂಡ್ ಈ ಕೇಸಲ್ಲಿ ಹೊರಗಡೆ ಬಂದಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸಿಗೆ ವಿ ಕಾಲ್ ಆಸ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಅಂಡ್ ಯು ಶುಡ್ ಡಿಫೈನ್ ದಿಸ್ ಆಸ್ ಲೈಟ್ ಆಫ್ particular frequency or suitable frequency anta helbeku. Now as you can see these pictures, idondu metal plate ide, fine. So as you can see illu light incident agide, same plate idu, illu incident light incident agide, illu kuda light incident agide, but here no emission is taking place, which means the frequency of incident light matters a lot. Suitable frequency na ee plate ge you have to incident. Okay, whereas if you see this diagram, illi enagta ide, electrons are emitting. Here the electrons are emitting with more energy. Okay, so e lightigu there is a difference in frequency. All right, wavelength different ide and frequency also differs. Illi frequency kammi ide, here the frequency is increasing, illi innu jaasti ide. So for the metal to liberate or ee metal inda electrons emit agbeku andre we have to provide some suitable frequency. All right, and that frequency is called as threshold frequency. Okay, 1 mark question idu. This threshold frequency is defined as the minimum frequency required by the metal for the emission of electrons is called as threshold frequency. Okay, so ee threshold frequency light na incident madidre matra electrons liberate agutte, like in this case and in this case. Since ee case alli frequency tumba kammi irodrinda ee metal surface will not emit any electrons. Okay, so this is about the photoelectric emission. Then the fourth one is secondary emission. Secondary emission anta helidre ee metal surface ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಬಂಬಾರ್ಡ್ ಮಾಡ್ತಾರೆ ಆರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದಾಗ ಫಾಸ್ಟ್ ಮೂವಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ again electrons will emit from this metal surface. This is called as secondary emission. It is defined as the process of emission of electrons from a metal surface by the bombardment of fast moving electrons is called as secondary emission. So this is about the types of emission of electron emission. Thermionic emission andre heat energy na incident ಮಾಡಿ electron emission ಆಗೋದು. Field emission means strong electric field na supply ಮಾಡಿ or the process of emission of electrons by the application of very strong electric field at the surface of metal is called as field emission. Photoelectric emission means the process of emission of electrons from a metal surface when radiation of or light of suitable high frequency is incident on the metal surface. Secondary means the process of emission of electrons from a metal surface by the bombardment of fast moving electrons. Now let's define this photoelectric effect, the phenomena of emission of electrons from the metal surface when radiation of suitable frequency are incident on them is called as photoelectric effect. I'll explain about it. See, here there is a metal surface, and this metal surface, as you know, as we know, will have electrons, and these electrons will be bound, andre they will not be free to get emitted. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಲೈಟ್ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತಾ ಇದೆ. ಓಕೆ, ಆ್ಯಂಡ್ ಲೈಟ್ ಯಾವ ಥರ ಲೈಟ್ ಆಫ್ ಸೂಟಬಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೂಟಬಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಲೈಟ್ ಆರ್ ರೇಡಿಯೇಷನ್ನ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿ ಈ ಮೆಟಲ್ ಸರ್ಫೇಸಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಷನ್ ಆದಾಗ ಈ ಹೋಲ್ ಫಿನಾಮಿನಾನ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಆಸ್ photoelectric effect. And the frequency, minimum frequency required for the emission of electrons is called as threshold frequency. See, illi liberate agidiyalla, these electrons are called as photoelectrons. These electrons are called as photoelectrons. So ee phenomena dinda current will be produced, that is, because of these electrons the production of current will take place, and that is called as photocurrent. Fine. The current produced due to these electrons is called as photocurrent. Now we will discuss about how this photoelectric effect was discovered. So in the year 1887, Hertz was performing one experiment with this setup. Idanna 2 marks ge they can ask you in exam, write Hertz observations anta keltare. Fine. History and all you no need to write, and even the diagram also you have to just pen down the observations. Okay, so for the sake of understanding I have taken the experimental setup. Actually in 1887, when Hertz was performing one experiment, he was performing the experiment to investigate electromagnetic radiation. Then accidentally he discovered photoelectric effect. So in the diagram, as you can see, this part is called as detector. Okay, detector or receiver, and idanna it's just a wire idu. All right, and idanna bend ಮಾಡಿ ಒಂದು ಸರ್ಕಲ್ ತರ ಶೇಪ್ ಕೊಟ್ಟಿದ್ದಾರೆ, and 2 metal spheres are here. This is one metal sphere and this is another metal sphere. Idanna I'll name it as S1 dash, S2 dash. These are the metallic spheres. So ಈ ವೈರ್ ಎರಡು ಎಂಡ್ ಅಲ್ಲಿ 2 metal spheres ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದಾರೆ, and there is a gap in between these metals. Okay, and electromagnetic radiations were produced using one induction coil. On the induction coil help in the EM waves were produced. Okay, and these are the plates. A and B are the plates, and idukku kuda metallic spheres na attach ಮಾಡಿದ್ದಾರೆ, S1 and S2. Fine. So the electromagnetic radiations falling on the detector induced a potential difference across the gap. Okay, so ಇಲ್ಲಿ electromagnetic waves ಈ region ಅಲ್ಲಿ produce ಆಗ್ತಾ ಇದೆ, and that those electromagnetic waves ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೆ ಅಂದರೆ high voltage sparks ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ. ಓಕೆ, ಇಲ್ಲೇನು ಬಂತು, ಹೈ ವೋಲ್ಟೇಜ್ ಸ್ಪಾರ್ಕ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಯಿತು. ದೆನ್ ಸೊ Hertz found that when this plates are illuminated with UV rays, ಈ ಪ್ಲೇಟ್ಸ್ನ ಮೇಲೆ UV rays ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇರೋ ಸ್ಪಾರ್ಕ್ ಇನ್ನೂ ಎನ್ಹ್ಯಾನ್ಸ್ ಆಯಿತು, ಇನ್ಕ್ರೀಸ್ ಆಯಿತು. ಓಕೆ, high voltage sparks were enhanced all the more when UV rays were made to fall on the emitter plate. So that was his observation. Okay, ಅದನ್ನ ಈ ತರನು ಹೇಳ್ಬೋದು. When UV light is incident on the metal surface, electrons ಏನಾಯಿತು, they absorb the energy from the incident radiation. ಸೊ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎನರ್ಜಿನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡಿಕೊಂಡಾಗ ಈ ಮೆಟಲಲ್ಲಿ ದೇರ್ ವಿಲ್ ಬಿ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ವಿಲ್ ಬಿ ಹೋಲ್ಡಿಂಗ್. ಓಕೆ, ಆ್ಯಂಡ್ ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಬ್ಸಾರ್ಬ್ ಇನಫ್ ಎನರ್ಜಿ ಟು ಓವರ್ಕಮ್ ದ ಅಟ್ರಾಕ್ಷನ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ಇನ್ ದ ಮಟೀರಿಯಲ್ ಆಫ್ ದ ಸರ್ಫೇಸ್, ದೇ ಎಸ್ಕೇಪ್ ಫ್ರಮ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಮೆಟಲ್ ಅಂತ ಹರ್ಟ್ಸ್ ಸೆಟ್. Okay, I'll repeat the experiment once again. So just this is the experimental setup. Induction coil na use ಮಾಡಿಕೊಂಡು he produced electromagnetic waves and one detector is there. ಈ detector ಏನು just a wire, two ends ಅಲ್ಲಿ metallic spheres ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ಈ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ಸ್ ಇಂದ ಈ ರೀಜನ್ ಅಲ್ಲಿ, ಈ ಗ್ಯಾಪ್ ಇನ್ ದ ಡಿಟೆಕ್ಟರ್ ಅಲ್ಲಿ ಸ್ಪಾರ್ಕ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯಿತು. ಸ್ಪಾರ್ಕ್ಸ್ ವರ್ ಪ್ರೊಡ್ಯೂಸ್, ಹೈ ವೋಲ್ಟೇಜ್ ಸ್ಪಾರ್ಕ್ಸ್, ಅಂಡ್ ದೀಸ್ ಸ್ಪಾರ್ಕ್ಸ್ ವರ್ ಎನ್ಹ್ಯಾನ್ಸ್ಡ್ ಯಾವಾಗ, ವೆನ್ ದ ಪ್ಲೇಟ್ಸ್ ವರ್ ಇಲ್ಯುಮಿನೇಟೆಡ್ ವಿತ್ UV light. So when electron gain enough energy to leave this metal surface, they can easily escape from this metal surface. So the study of the discharge through gases at low pressure led to many historic discoveries. We'll see the discoveries one by one. So William Crookes in 1879 discovered cathode rays, and Röntgen in 1894 discovered X-rays. Fine, and in between there is one more discovery, that is in 1887, which we had already discussed. Heinrich Hertz conducted one experiment on photoelectric effect. Next, J.J. Thomson in 1897 found that cathode rays are nothing but stream of negatively charged particles. He experimentally determined the speed and specific charge. Specific charge andre ratio of charge to mass anta. Numerator alli charge, denominator alli mass tagondre we call it as specific charge. Okay, so of the cathode ray particle in 1897, J.J. Thomson experimentally determined speed as well as specific charge of the cathode ray particles, and the particles in the cathode ray were found to travel with the speeds ranging from 0.1 to 0.2 times the speed of light, which means 3 into 10 to the power of 8 meter per second. Okay, so next in 1913 R.A. Millikan conducted one oil drop experiment, and he made a precise measurement of the charge of an electron. He found in his experiment that the charge on an oil drop was always an integral multiple of elementary charge, that is 1.602 into 10 to the power of minus 19 coulomb. Millikan experimentally established that the electric charge is quantized and the charge of an electron is how much, 1.602 into 10 to the power of minus 19 coulomb. Okay, then in 1895 the in 1897 discovery of electron was made, as I had already mentioned here, and this oil drop experiment in 1930. So many experiments were conducted and many more discoveries are also made with regard to these experiments. Okay, so just remember, William Crookes discovered cathode rays, Röntgen discovered X-rays, J.J. Thomson discovered electrons, okay, which means he said cathode rays are nothing but stream of negatively charged particles, and Millikan, he conducted oil drop experiment and he established that the electric charge is quantized and charge of an electron is 1.602 into 10 to the power of minus 19 coulomb. So in today's video we had discussed about a brief introduction, then we had discussed about the Hertz experiment, electron emission and few basic discoveries. So this was all for today. Keep studying and thank you for watching.